This is the solution of the Waterloo math competition, which is a CEMC Gauss contest for grade 7. I start from number 11. If you have any question from number 1 to 10 or any other questions, then please feel free to make any comment on this video. Let's go to number 11. So from number 11, this is part B. And during this exam, you can use the calculator as you wish. So let's go further. So P plus Q, P3, Q4, so 7. And number 12, the length of the rectangle is twice its width. So if this is W, this is 2W. So perimeter of the rectangle is 120. So whole perimeter is 6W, becomes 112. So W is 20. And 13. Louis purchased the number of water hand pumped to give to charity. Mean price was 85 per water pump. So spent total 765. How many water pumps did she purchase? So we need to think about the way to find the average, like arithmetic mean. We add them all together. For example, A plus B plus C, divide by the number of data, which is n. This becomes the mean. So now, when we add all together, this was a 765. We don't know how many was there, but the mean was 85. So n equals 765 over 85. So 765 divided by 85 becomes 9. Number 385 is 3 prime numbers. Okay, so 385 has a 5, 77, and 7, 11. So sum of 5 and 7 and 11, 23. Now circle has radius 2. Radius circle is tripled, which is 6. The area of original circle is pi r squared, which is 4 pi. Divide by the area of the new circle, which is pi r squared, 36 pi. So this becomes 1 over 9. Bread and gelatina each have a glass containing 300 milliliters of water. Pours half of his water, 20% of our water into bread glass. So the beginning, 300 and 300. So first step, this says bread and this is gelatina. So bread gives half to gelatina, now 450 and 150. And gelatina pours 20% of her water. So 450 times 0.2. So which is 90. So 240 and 360. What volume of water is now in bread glass? 240. Circular spinner is divided into 12 identical unshaded sections. So this is 12, okay. And 3 identical shaded sections. And each unshaded section is 3 times the size of each shaded section. So if, let's say, if this size is 1, this size 1, then this size is 3, 3, 3, 3, 1, 3, 3, 3, 3, something like that. So we have this shaded one, 3, and unshaded one, 12. So if the shaded one of this shaded sector has the size 1, then this whole circular spinner has the area of 39. So what is the probability that the arrow stops in the shaded section? So shaded section is 3, and the whole, the plate is 39, so 1 over 13. Gauss factory assembled robot. Each robot comes in one of three colors: red, blue, or green. 1, 2, 3, 4. And robot assembled is the first robot to have the same color. The number previous. Okay. So this is red, blue, green, red, blue, green, red, blue, green, something like that. 1, 2, 3, 4, 1, 2, 3, 4, 1, something like that. So actually this is asking about the LCM, least common multiple, 3 and 4. So this is 12. So after the 12th robot, it starts again from red and 1. Number 19. 5 different integers in the list, median 10. And different integer has median 10 and range of 7. The smallest possible integer. So if this is median, this should be, make it 11 and 12. Because this is asking about this smallest possible integer. So if we go further, let's say 13, 15, then this is 9 and 8. This is this is not small enough in this case. So let's go 11 and 12 and go until 5. So smallest possible integer can be 5. It has 31 high settings and from 1 to 31. And the up button goes up 6 settings at a time, and the down button goes down 4 settings at a time. So otherwise it does not move. So setting number 1, how many of 31 settings will the desk be able to stop it? So I start from number 1, and since I cannot go down from here, I need to go up. So 6, so I arrive number 7. So from here, for example, if I go up another 6, then I go until 13. But if I go down 4, then I arrive number 3. And from number 3, if I go up another 6, I go to number 9. And if I go down another 4, then I reach number 5. And go up number 11, something like this. So actually this is very easy, not easy, but we can guess. Wherever we reach is all the odd numbers. Because odd number plus even number, always odd number. So from 1 plus 6 goes to odd number, minus 4, odd number, plus 6, minus 4, always make odd number. So actually this is the question which is asking us how many odd numbers from 1 to 31, which is 16. Number 22. So now this is 2 by 3 grid of squares, and it uses 17 to speak like 3 and 3, 2 and 2 for the outer side. Okay, and inner side 2 times 2, 3 times 1. So let's write it down. So this is 2 times 2, which is 3 minus 1. And this is 3 times 1, which is 2 minus 1. So let's say now we have 20 times 24. So the outer side 20, 20, 24, 24. And inside is 20 times 23, which is 24 minus 1. And like these vertical lines, and the horizontal lines 24 times 19. So what we need for to speak 20 times 2 plus 24 times 2, this is for outer, and 20 times 23 plus 24 times 19, this is for inner. So the question is, it is asking about the inner to speaks the percentage. So 20 times 23 plus 24 times 19. So I guess this could be the pattern. So 20 times 23, I'm calculating with my calculator. 24 times 19 divided by 20 plus 24 is 91%. So this is the one. Rectangular prism has integer edge length and has the volume of V. So maybe it is like this: A, B, C, all integers. And it is painted. And it cut into 1 by 1 by 1 cubes. Okay, so when we check 1 by 1, only 50 cube have no panes on them, which means very inside here has 50 cubes. So this one may be A minus 2, because from the edge 1 and 1, so this will be A minus 2, and this is B minus 2, and this is C minus 2, which I just subtract the cube who has any panes on it. So A minus 2, B minus 2, C minus 2 is the 50. So we need to figure it out. What is the possible A, B, C? So let's say A minus 2, B minus 2, C minus 2. 50, when we multiply them together, can be 1, 150, 1, 2, 25, 1, 5, 10, 1, 10, no, because it's repeated. 125, oh, already we have it. So there's no more possible. What about 255? So only these are possible. So 50, 25, 1, 2, 5, 25, 10. I think this is the only one, which means A, 3, 3, 3, 4, 3, 4, 7, 7, 52, 27, 12, 7. So the volume, the original volume will be 9 times 52. I'll just calculate it directly here. 9 times 52 plus 12 times 27 plus 21 times 12 plus 4 times 49 divided by 4, because we need to find the average. Oh no, I made a mistake. So when I calculate it, it is 310. And 3-digit integers that make integer from 100 to 999 inclusive. 3-digit integer is called tiny when no rearrangement of its digits gives a 3-digit integer that is smaller. Okay, so 138,207,566. Okay, so if we have 0, it's a little bit different story. So I will exclude the 0 first and include it later. So for example, if you use only the digit from 1 to 9, which is 9, and 3 different numbers, then let's say 1, 2, 3, or 7, 6, 4, let's say. Whatever we have 3 digits, just we can arrange it with the smallest possible number. So if we have 364, then we can just arrange it 467, for example. So which means among three numbers, we can have just three numbers without considering the like order. So this is a like combination. So let's pick three numbers: 9, 8, 7. So we can pick the first number out of 9 digit and 8 digit and 7 digit. But if we leave it just like this is considering the order, because first, second, and third. So let's say if I select 1 and 2 or 2 and 1, this is the same. 1 and 2 and 3, 3 and 1 and 2, 2 and 1 and 3, and 3 and 1 and 2, let's say all are same. But this consider as all those are different cases. So now I will put some calculations to make them all like as a one case. So if let's say if I have 1, 2, 3 digits, then I need to remove the possible arrangement. So this arrangement can be 3, 2, 1. So I divide by 3 to 1 here. Then in this case, actually we don't think about the order of the numbers. So 3, 4, which is 84 plus. So at this moment we think about the case of the three different digits without 0. So now two different digits without 0. So for example 1 and 2. Then in that case we can make 1, 1, 2 or 1, 2, 2, for example. So let's choose only two numbers, 9 and 8, but we need to remove the consideration of the sequence like order. So 2 times 1. So it's 36 ways. But because if we have 1 and 2, then we can make 1, 1, 2 or 1, 2, 2. So actually this is not 36, we can make it 72. So and only one digits, we can make it 9, because now still we are considering the digits without 0. And if we have 1 zeros like this, actually this is and 1 0, but how can I say, 2 digit different, let's say 2 and 7, not 2 and 2, for example. So 2 digit different is the same case like this. So that is 36. Oh, this is 72. Sorry. 36 plus. And if we make it the same digit, like 202, 101, let's say, that is 9 cases. So this has no zeros. This has 1 0. And now we have 2 0, which is 9. No, 1 0 is this one. Was it? Sorry, I'm a little bit confusing. No, this has no 0, 3 or same. So this is 2 zeros, like 100, 100, 200, something like that. 2 zeros. So altogether, 18. So 27. So 219. This is how I found. And number 25, suppose that 8 different prime numbers, w, x, y, 234, y and z is less than 50. Here, you know, odd numbers. Let's say if we add 3 odd numbers, let's say 5, this becomes odd number, which is 9. But this is even number. It means maybe one of them is even number. So 2, 3, 5, this is even number. Because now we are talking about prime numbers, so we need to make the cases a little bit more concentrated. So now we understand one of these can be 2. So this one, x plus y, x and z. Okay, now I understand. So x is 2. Because if x is not 2, as I told you, odd plus odd is even number, which is not prime number. Only 2 is prime number in even number. So x should be 2. So for example, if y is 5, we can make 7, which is prime number. So now we know x is 2. So x is 2. And let's find another one. Let's say y is 5. Then 2 plus 5 is 7, which is valid. 234, this is the multiple of 3. So z should be 5, like a 3 cannot be the case because 3 also multiple of 3. Multiple of 3 plus multiple of 3 is still multiple of 3, which is not prime number. So z is, if z is 5, 239, let's say, and 229, I think this can be the, okay, so not y. Let's say z is 5. And then let's find y. So now x is 2. And let's say if y is 3, then w is 229, which cannot be because, okay, it doesn't make sense because we have this same, because it's all different. So y is not 3. And what is, let's say 11? 11 and 13 both. So for example, if 2 and 11, 13. So 2, 2, 1. 2, 2, 1 is prime number. So w minus y is 210. So this is like a trial and error. You guess some number and you just match to the conditions.